Welcome to the Chemistry, Biology and Math Revision Hub. Today we're doing the PS1 Excel International A-Level Chemistry Unit 6 for January 2024. Let's begin with the first question. In question 1, a student carried out some tests on 4 aqueous solutions labeled A, B, C, and D. Each solution contained 1 cation and 1 anion. They say complete the table. The first test, dilute aqueous ammonia was added drop by drop to 4 centimeters cubed of A until there was no further change. The observation was a pale blue precipitate formed which dissolved to give a deep blue solution. Because the pale blue solution turned to form a deep blue solution, this should be copper 2+. And next they say dilute aqueous ammonia was added drop by drop to 4 centimeters cubed of B until there was no further change. A white precipitate formed with the first few drops and the precipitate dissolved in excess ammonia to form a colorless solution. This is going to be zinc 2+. It's a non-transition metal which is going to form a colorless solution. So the white precipitate was due to that. They say the formula of the complex ion which forms in the colorless solution. This is going to be this due to the ligand substitution reaction that occurred. And next they say dilute aqueous sodium hydroxide was added drop by drop to 4 centimeters cubed of C until there was no further change. The inference is the cation in C is ion 3+. The observation should be a brown precipitate forms, and this precipitate does not dissolve in excess. The next they say dilute aqueous sodium hydroxide was added drop by drop to 4 centimeters cubed of D until there was no further change. When this occurred, an off-white precipitate formed, which did not dissolve in excess but darkened when left to stand. The off-white is going to be due to manganese 2+, and of course, it turns brown when it darkens, moving from manganese 2 to manganese 3 and then 4 as it turns brown. And next they say name the type of reaction which results in the darkening of the off-white precipitate. This is going to be oxidation. The oxygen in the air is causing the oxidation reaction. In part B, adding dilute nitric acid followed by aqueous silver nitrate to A and B resulted in both forming precipitates. The student was not certain, but suggested that the anion in A was chloride ion and the anion in B was bromide ion. They say state why the student was not certain and outline a further test which could be carried out to confirm the presence of both these anions. The student was not certain because bromide forms cream and the chloride forms white precipitates. However, these precipitates are hard to distinguish, so to the precipitates they add dilute aqueous ammonia. The precipitate containing chloride ion will dissolve, while that containing bromide ions will not dissolve. In part C, the student tested for the anion in C by adding acidified barium nitrate solution and observed a white precipitate. This is going to be barium sulfate. Give the formula of the compound in solution C. Because the cation was ion 3 and the anion is sulfate due to the white precipitate formed here, this is going to be ion 3 sulfate. And in D, they say the student researched further tests for the anion present in D. A test was found which involved the addition of sodium hydroxide solution followed by aluminium and then heating strongly. Ammonia gas was given off. Suggest a possible anion present in D. The anion present in D is a nitrate. But of course, marks are going to be awarded for your level for any nitrogen containing anion, although this is a perfect test for a nitrate anion. So this brings us to the end of question 1. Let's continue to question 2. In question 2, this question is about the identification of 4 different organic compounds, W, X, Y, and Z. The molecules of each compound contain a total of 3 carbon atoms and only 1 functional group. A sample of W gave a positive result with Tollens reagent, meaning this is going to be an aldehyde. If the positive result and the displayed formula of W, the positive result is a silver mirror forms, and this is going to be an aldehyde. However, since this is a 3-carbon containing compound with only 1 functional group, this is going to be the formula of that compound. In part B, a sample of X produced a sweet-smelling substance when warmed with ethanoic acid. Of course, this could be an ester, and a few drops of concentrated sulfuric acid. Name the functional group in X identified by this test. This is going to be an alcohol. Then they say there are only 2 peaks in the carbon-13 NMR spectrum of X. Draw the displayed formula of X labeling the carbon environments. Now remember, all these compounds contain 3 carbons but only 1 functional group. Since we have identified that it has OH, meaning it's an alcohol, and it has only 2 peaks, this is going to be the structure. This is the first peak, and that is the second environment actually. First environment and the second environment creating this secondary alcohol. A sample of Y gave a positive result when warmed with an alkaline solution of iodine. Give 2 observations of a positive result from this test. Because this is the iodoform test, remember they talked about an alkaline solution of iodine. The observation is going to be a pale yellow precipitate and an antiseptic smell. That is going to be triiodomethane. The next they say identify Y by name or formula. Based on the information we have, Y is going to be propanone. This is the structure, and here is the name. In part D, they say a sample of Z produced bubbles when sodium carbonate solution was added. This means there is a carboxylic acid. So they say draw the displayed formula of Z showing all the bonds. Since this is a carboxylic acid with 3 carbons, it's going to be displayed as that, and that should be the answer. So this brings us to the end of question 2. Let's continue to question 3. In question 3, a student was given a 0.02 mole per decimeter cube solution of ammonium vanadate 5 and asked to prepare solutions containing vanadium ions in different oxidation states and then to confirm the results. The student decided to use the 3 different reducing agents shown. There is zinc, there is sulfur dioxide, and tin. In part A, a student pipetted 25 centimeters cubed of vanadate 5 solution into a flask and added about 60 centimeters cubed of 1 mole per decimeter cubed sulfuric acid. About 5 grams of granulated zinc was added to the flask. Cotton wool was used to stopper the flask, which was heated and gently boiled for 30 minutes. Suggest why only an approximate volume of sulfuric acid was used. An approximate amount of sulfuric acid was used because they didn't care about its concentration since it was in excess to ensure that all the vanadate 5 reacts. The next they say the cotton wool helps to prevent the reoxidation of vanadium and to allow the escape of hydrogen gas. State why hydrogen gas was produced. You may include an equation in your answer. If we look at this reaction, we can see zinc is reacting with sulfuric acid, and again this is a metal reacting with an acid to form a salt and hydrogen. So we can say that zinc reacts with the sulfuric acid and then hydrogen gas is going to be produced. Next they say give a possible reason why the flask was heated. Again, heating is to speed up the reaction, provide more kinetic energy for faster collisions so that the rate can increase. In the next part, the student concluded that zinc had reduced the vanadium 5 to vanadium 2 oxidation state. Explain the sequence of colors that the student would have seen to reach this conclusion. They say link each color to the vanadium oxidation state. There is yellow due to vanadium 5, there is blue due to vanadium 4, there is green due to vanadium 3, and there is purple due to vanadium 2. In part B, the student was told that sulfur dioxide is toxic and the cylinders of the gas are not recommended for use in schools. The student was advised to prepare it within the reaction mixture from sodium sulfate and hydrochloric acid. Suggest why sulfur dioxide is advised to be prepared in this way. If it's prepared in this way, the chances of the gas escaping from the reaction mixture are going to be decreased. So I say there is a low chance of the gas escaping from the reaction mixture in comparison to when a cylinder is used. And next they say write the equation for the generation of sulfur dioxide from the reaction between sodium sulfate and hydrochloric acid. State symbols are not required. So using sodium sulfate 4, we can see, which is what we see here, plus hydrochloric acid gives us a salt which is sodium chloride plus a gas which is sulfur dioxide and water. So to balance the equation, I put a 2 here because there were 2 sodiums, and then everything would be fine. In part C, after using tin as the reducing agent, the student carried out a titration with acidified potassium manganate 7 to find out how far the vanadium had been reduced. They say state a suitable method to remove the unreacted tin. Because the unreacted tin is going to be in solid state, filtration is an appropriate method to remove it. Information about the experiment is shown. 25 centimeters cubed to 0.02 mole per decimeter cubed. Ammonium vanadate 5 was reduced by tin. 20 centimeters cubed to 0.01 mole per decimeter cubed. Potassium manganate 7 was required to oxidize the vanadium back to its original oxidation state. The manganate 7 half equation is given here. They said it used the vanadium ion oxidation state after the reduction by tin, and you must show your working. So since we're given the concentrations and the volumes, I began by finding the number of moles of manganate 7, which is concentration times volume, and again 0.01 times the volume. I divided by 1000 to convert it to decimeters cubed, and so my moles were that. Also, I found the moles of ammonium vanadate, still concentration times volume, in decimeters cubed, and I got that. Now, the ratio of manganate to vanadate is going to be that to that, which gave me a 1 to 2.5, which you could possibly convert to 2 to 5. If we look at the reaction, the manganate is going to be converted to manganese 2, and in this reaction, 5 electrons have to be gained per mole. If 2 moles are required, it means 10 electrons have to be gained. So the reduction is going to occur twice in this case, meaning the previous reduction could have occurred twice as well. And again, if you read here, I said in each oxidation of the vanadium species, using manganate, 5 electrons are required, so 10 electrons are required if the oxidation occurred twice to regenerate the vanadium 5. And again, we're talking about the regeneration. It means previously it was vanadium 5 and the reduction occurred until vanadium 3. So the final oxidation state when tin was used to reduce was vanadium 3. And then they say explain the effect on the titer of leaving the tin in the reaction mixture. It means more manganate would be required to reoxidize the vanadium as well as reoxidize the tin. So this brings us to the end of question 3. Let's continue to question 4. Question 4. This question is about the preparation of phenyl ethanamide by the reaction between phenyl ammonium chloride and ethanoic anhydride. So this is ethanoic anhydride, this is phenyl ammonium chloride, and then we produce phenyl ethanamide and the other compounds. This is a carboxylic acid and then HCl. They've given us the data in the table about the molar masses, the density, as well as the melting temperature. So there is an outline procedure. They say in step 1, dissolve 1 gram of phenyl ammonium chloride in 30 centimeters cubed of deionized water in a flask. Then dissolve 6 grams of sodium ethanoate in 25 centimeters cubed of deionized water in a separate conical flask. Carefully add 2 centimeters cubed of ethanoic anhydride to the phenyl ammonium chloride solution and stir until all the ethanoic anhydride has dissolved. Then add the solution of sodium ethanoate and continue to stir for a further 3 minutes. Collect the impure sample of phenyl ethanamide by filtration under reduced pressure. Recrystallize the phenyl ethanamide using the ionized water and then determine the melting temperature of the crystals of phenyl ethanamide. In part A, the use of phenyl ammonium chloride is preferred to the use of phenylamine in this preparation. So we can see the information given, and then this is a solid, that is a liquid, and then we see the hazard symbols. This has environmental hazard, health hazard, environmental hazard, health hazard, toxic, and then corrosive. So we can see this has more hazard labels or hazard symbols, or you could say it's more hazardous than the phenyl ammonium chloride. This is suggested by referring to both columns of data in the table, 2 reasons why it is preferred to use phenyl ammonium chloride. The phenyl ammonium chloride is a solid, so it's going to be easier to handle in comparison to the liquid. And then the phenylamine has additional hazards like corrosive and toxic, in addition to being an environmental hazard and a health hazard. Then in part B, show by calculation that ethanoic anhydride is in excess in this preparation. Here I used the information in the table from the previous page. We're given the density, and then there is some information here about mass and so on. So the mass of ethanoic anhydride, which is density times volume, which is 1.08 times 2, giving me that. The moles of mass divided by molar mass, which is this mass, divided by the molar mass from the table, giving us that. The moles of phenyl ammonium chloride are mass divided by the molar mass, which is 1 gram divided by the 129.5, giving me that mole. So the mole ratio of the anhydride to ammonium chloride is that to that, which is going to be 2.75 to 1. The mole ratio should be 1 to 1, but it is 2.75 to 1. So we can conclude that ethanoic anhydride is going to be in excess. And in part C, in step 4, a Bachner flask and funnel were used for suction filtration. The filter paper used should fit in the funnel and lie flat on the base of the Bachner funnel rather than curl up the sides of the funnel. They're talking about this instead of that. They say explain why it is important to place the filter paper in this way. When it's flat, it means all the holes are going to be sealed, so the solid sample cannot escape through the holes. So I say the flat filter paper ensures that the holes of the Bachner funnel are fully or completely covered. The incorrectly placed filter paper will enable some solids to pass through. Explain why the solid collected in step 4 is washed with a small volume of cold water. This is done to remove any soluble impurities. And again, remember the solvent used can dissolve the solid, but if it's in cold conditions, the dissolution is going to be lower. So cold water is used to prevent the solubility of the crystals into the water. In part D, they say, in step 5, the recrystallization of phenyl ethanamide involves hard filtration. State the purpose of this filtration. This is done to remove any insoluble impurities. And in part E, they say, give the two effects of impurities on the melting temperature range of phenyl ethanamide. The melting temperature is going to decrease because, of course, this is an impurity. The range of the melting temperature is going to be wider. Then in part F, they say an infrared spectrum of phenyl ethanamide and an infrared spectrum of phenylamine were obtained. One of these spectra is shown with two peaks circled. So there is this peak here and that peak. Infrared data for some organic functional groups are shown. Explain why peak 1 cannot be used to identify the spectrum as being produced by phenyl ethanamide, but peak 2 can. Because this is an amide, we will look for the carbon-oxygen bond present in amides. This peak here is present in both amides and amines. However, the carbon-oxygen double bond peak in amides is going to be present only in amides, and this is going to be peak 2. So here I say peak 1 can be due to an amine in that stretch, or due to an amide in that range. Peak 2 is only due to the carbon-oxygen bond in amide, which is that, and this peak will be missing in the amine because amines don't have a carbon-oxygen double bond. So this brings us to the end of question 4 as well as to the end of the whole paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.